Regression is a fairly simple topic with a lot of complex math behind it. So often we like to use technology to help us with this concept to get the results that we are desiring without having to labor through a lot of the mathematics. So we're going to use Microsoft Excel in order to help us with this concept of regression. Realistically, the concept of regression is as simple as this. Can I fit or find an equation that models my data really well? So we first want to start with getting a visual description of our data through a scatter plot. So I'm going to highlight both columns of data. I'm going to hit Insert, and over here in Chart Type, underneath Scatter, this first option, compare pairs of values is what I want. So I'm going to select that option and it'll automatically create a scatter plot for me. Now we're going to do the normal things here where we highlight the chart area. Underneath Chart, we click Format. We can change our chart title. This is going to be number of graduates number of graduates, and then I'm going to collapse that. We're now going to look at the legend. I'm actually just going to turn that off since we only have one set of ordered pairs. Horizontal axis, turn that on, scroll down, and turn on the axis title. And here we're going to go ahead and just say year. Okay. And then we'll collapse that. Vertical axis, we will go ahead and turn on that title, and we will label that as number of graduates, and then in parentheses I'm going to say millions. So we've got all the chart elements that we need to make sure we know what this data is representing. But where we really want to go is there this data looks really well correlated. In other words, as the year increases, so does the number of college graduates. So we observe visually that there is a really good relationship between these two variables. But I want to add a trend line, is what Excel calls it. I want to add a trend line that actually has an equation associated with it that models this data. So I'm going to start by turning my trend line on underneath my Series 1 drop down. And then I want it to do two things. I want it to display the equation, and I want it to display my R² value. And look at what it does. It takes and finds the line of best fit, the line that goes through my data the best. Here is the equation of it. Right now, trend type is linear, so there's a linear equation, and I have an R² value of 0.9895. which is a fairly strong R² value. Okay, and one of the things I don't like about Excel Online as opposed to the desktop version, in the desktop version, it puts this in a text box that I can move around and change the font of and things of that nature. Unfortunately, in this version, I can't, and what we're going to find is in other charts that this is going to end up right on top of the line, but I can't move it. Don't worry about it. We'll move forward anyways, even though we don't have that ability to edit. And so what do we have here? We have a scatter plot with our axes and chart title appropriately named. We have our trend line and we have our R² values. These are the elements that you want for the regression project. Now, before we look at the two other examples that we want to look at, underneath trend type, I have several different options. I can look at my data here and go and know that it's going to be linear. But look at the other options I have. The two other options that we want to illustrate are exponential and logarithmic. So we're going to take a look at those in the next two examples. So speaking of our next examples, I've got a second sheet here with a second set of data. This is population, should label that a little bit more, of rabbits. So there's a breeder who has a pair of rabbits. So the very first generation, he has a pair of rabbits that he's going to breed. And this then is the value of how population of rabbits at his second generation after he breeds the first two for the first time. Third generation, fourth generation, fifth, sixth, and seventh generation. Let's go ahead, select that, and we want to turn this into a scatter plot. We can already tell without updating anything that this data is definitely not linear. If you remember anything about function types, you're looking at this probably and thinking exponential. So let's go explore that. So in here, horizontal axis, we're going to turn that on, and we're going to say generation. And then vertical axis, we are going to turn that on, axis title on, and say population. And back up here, I missed the chart title, so we're going to go up here, change our chart title to population of rabbits. Close that down, and then legend we're going to go ahead and just turn off. So we have our chart nicely outfitted here, but what we want to do next is click on series and down here and turn on trend line. You can see that it'll automatically always start with a linear. We want to display equation and display our r-squared value. Linear doesn't do so good, and an r-squared value of 0.79 isn't the greatest. And we can just visually see that this doesn't do a good job. So what I'm going to do is I'm going to click here and I'm going to switch this to exponential. And immediately it models the data much more accurately. You can see that your r-squared value significantly increases. So we have a scatter plot showing the relationship between the population of rabbits as dependent upon what generation it is that this specific breeder is on with his rabbit breeding program. And then also we have the equation of an exponential model, an exponential trend line with its r-squared value. Let's click on sheet 3 here, our third tab, to take a look at one final example. Here I have age and height of a person. Okay, so at age 1 they are 25 inches tall. At age 3 they're 37 inches tall. All the way down to age 21 they're 66 inches tall. Let's go ahead and look at the visual relationship between these two variables. So we create our scatter plot, and you can see that we definitely have a different pattern here than normal, or than the other two I should say. This is a fairly normal pattern, but it's different than the linear and exponential. I know that a little line is not going to model this well, nor is an exponential, which I know slopes up. Okay? What do we know about height with a human? We know that we accelerate in height fairly quickly while we're young, but the older we get, we slowly but surely level off until we reach a peak value. Any data that behaves in that nature often follows a logarithmic pattern really well. So with that said, let's go ahead and turn off the legend, chart title. We're gonna say height at various ages. We'll close that down, turn on horizontal axis, turn that on, and that will be age in years. Turn off the collapse the horizontal, open up the vertical, turn on its axis title, and that's going to be height in inches. We'll go ahead and collapse that back down, and last but not least, series 1, turning on our trend line, and display equation on chart, display r-squared value. You can see that again the line doesn't model the data very well. There's very obviously, even with a line on it, it makes it more obvious that there's a curve there. We know it's not going to be exponential because that's going to go the wrong direction. So let's try logarithmic, which we know models things really well, that we see growth up front that levels off somewhere. And sure enough, that models it really well. But you can see we have that issue where it put the equation and the r-squared value right on top of our trend line and data points, making it very hard to read. And unfortunately, it's not selectable to be able to move around. Don't worry about that in this project. I can see that it's put there. So we have a linear example, an exponential example, and a logarithmic example.